Hi everyone, my name is mcbeth and I will be discussing with you what the agent of H3N2V disease, which is known as swine flu, is. I will describe its temporal variation and I'll also discuss what epidemiologists and researchers are doing concerning research. It is known that influenza viruses with pandemic potential may arise in pigs because pig cells express both human and avian influenza virus receptors, which then provide an opportunity for adaptation of avian influenza viruses and reassortment with human viruses when they infect the same cell. Influenza viruses cause annually recurrent epidemics which result in approximately 3 to 5 million cases of severe illness and 250,000 to 500,000 deaths worldwide. Infection with influenza viruses results in protective immunity, which is at least in part mediated by antibodies against the viral surface glycoproteins HA and NA during circulation in humans. The virus gradually accumulates point mutations in HA and NA, which allows the virus to escape host immunity. This phenomenon, also known as antigenic drift, explains the occurrence of seasonal influenza epidemics. The introduction of a new virus subtype that has not been previously circulating in the human population is referred to as antigenic shift. Antigenic shift occurs upon the introduction of an influenza A virus from the animal reservoir with or without reassortment. That is to say, the mixing of genes from two or more animal and human influenza A viruses. While influenza viruses are continuously changing by antigenic drift, antigenic shift happens only infrequently. To give you some history of how the H3N2V came about, we have to go back in history. In 1918, there was the Spanish influenza pandemic caused by an H1N1 virus, identified as the deadliest single event recorded in recent human history, killing as many as 50 million people worldwide. In 1957, there was the Asian pandemic, whereby the H2N2 virus emerged upon reassortment between human and avian influenza viruses. In 1968, the circulating H2N2 virus was replaced by the Hong Kong H3N2 virus, which continues to circulate in humans to this day upon reassortment between avian and human influenza viruses. This time, HA and PB1 segments of the H2N2 virus were replaced by an avian H3 virus. Then in 1977, H1N1 was reintroduced as the Russian H1N1 virus, which was genetically very similar to viruses circulating in the early 1950s, suggesting that the 1977 H1N1 virus was accidentally released from a laboratory. Subsequently, these subtypes co-circulated in humans until the Russian H1N1 virus was replaced in 2009 by the pandemic H1N1 influenza virus, which was actually identified as the AH1N1 PDM09. This was a reassortment virus that contained the NA and matrix M genes from the Eurasian swine influenza virus lineage, while other genes originate from a triple reassortment swine flu influenza virus that had previously acquired its genes upon reassortment between human, avian, and classical swine influenza viruses. This reemergence after reassortment in swine supports the hypothesis that swine can serve as a mixing vessel for the generation of new human influenza viruses. And now, for your viewing pleasure, I'm going to show you a 1-minute video that demonstrates how one can be exposed to H3N2V. So, what should researchers and epidemiologists do? With what is already known about the swine flu virus, experts are still left with questions about how swine influenza viruses jump to humans, which has left gaps in knowledge about how to best protect people and pigs from new flu viruses. In 2009, person-to-person transmission was identified in 15 cases, all in children younger than age 10, but the researchers found no evidence that the virus passed easily to other people. Lab analysis of the virus samples showed all were nearly identical and all were susceptible to neuraminidase inhibitors. Infections were mostly self-limiting, marked by fever, coughing, and fatigue. There was one notable finding: about a quarter of the patients reported eye redness or irritation, not usually seen with seasonal flu infection, but is known to occur in H7 avian influenza infections, as well as with the children who were hospitalized with 2009 H1N1 influenza. So, for now, it's unclear if conjunctivitis is an indicator of swine flu infection. It was also noted that direct contact with swine on multiple days before getting sick was a distinguishing characteristic of patients in the outbreak, with nearly 2/3 having had swine exposure on more than one day, and more than a fourth had daily exposure of the week before they got sick. Researchers stated the outbreak highlights the need for continued collaboration between animal and public health agencies in tracking and responding to novel influenza A viruses. Agricultural fairs are a known risk factor for swine flu virus infections in humans, but now the epidemiologic data has never been stronger or more geographically widespread. Researchers point out that despite the 2009 H1N1 pandemic and now the H3N2V outbreak, scientists still don't have a clear understanding of the dynamic ecology of swine flu-like viruses that circulate freely between pigs and people, citing that instead, and I quote, "We must often wait for humans to serve as sentinels through their infection with such novel viruses." Necessary studies include looking at large commercial farms as well as small hobby farms where fair pigs are raised, which could provide clues in reducing the risk of cross-species flu transmission. Recent studies have found evidence of aerosol swine flu spread, which may make current biosecurity steps obsolete. China is doing research involving human and animal health specialists, as the country is home to most half of the world's pork production. Large government-owned farms aren't threatened by research, and the nation has a strong scientific and lab network to support the work. So far this year, in 2014, only 18 H3N2V infections have been detected, all of them in people who were exposed to pigs at fairs. Health officials are unsure what factors have led to the dramatic drop in cases. Possibilities might be that the CDC and U.S. Department of Agriculture efforts at swine flu shows are working, or that newer swine flu strains that cause fewer human illnesses have edged out the H3N2V virus in the U.S. pigs. Or perhaps there are fewer swine show participants are seeking testing, or even fewer people are taking part in swine shows. So, what are the experts telling the public to do to protect oneself from transmission? So before, during, and after an exhibition, one will want to have a veterinarian perform health checks on the animals before they are admitted to and during the event. Monitor animals for signs of illness and consult with a vet if animals appear ill, and remove the sick swine immediately. Don't eat, drink, smoke, use pacifiers, or push strollers in areas that house animals. Other protocols should include, before an exhibition, learn signs of influenza A and other illnesses, keep accurate records on exhibited animals and farms of origin to trace back and communicate if an outbreak occurs. Attendees over the age of 6 months that attend livestock exhibits should have an annual influenza shot. As an additional precaution, those having risk of influenza complications, such as elderly, young children, pregnant women, and those with long-term health issues, should avoid direct contact with at-risk swine, and if ill, stay home. During an exhibition, the fairground should communicate with exhibitors about all aspects of monitoring and reporting protocols, ensure adequate and convenient hand washing stations, and post signs reminding people to wash their hands after being in contact with animals, after using the bathroom, and before eating. And to notify public health officials if people become ill at the exhibition, and individuals feeling ill should refrain from visiting livestock areas and seek medical care. After an exhibition, clean and disinfect exhibition areas, equipment, footwear, clothing, and vehicles. Incubate animals for at least a week. Contact a health professional if humans become ill after attending a swine or other livestock exhibition. Okay, everybody, it's Rumble! It's time for you to answer a few bingo questions. Okay, pens and pencils ready? Poised? Got your game cards? Okay, here's the first question. What is the mixing of genes from 2 or more animal and human influenza A viruses, also known as? Question 2. How can one be exposed to the H3N2V virus? Question 3. So far this year, in 2014, only 18 H3N2V infections have been detected, all of them in people who were exposed to what? Question 4. What are the experts telling the public to do to protect oneself from transmission of H3N2V? Question 5. The agent of H3N2V disease, which is known as swine flu, is a what? Question 6. The H2N2V virus emerged upon reassortment between which human and avian influenza viruses? Well, that's it for now. I'm Belle McBeth, and now back to the class to resume the H3N2V presentation with Daniela, Roman, and Dominique.